everyone, this is Kalpana here. In this video, we are going to solve the given differential equation which is non-exact. So let's get going. Problem. Solve 2x square y minus 3y square into dx plus 2x cube minus 12xy plus log y into dy equals to 0. Solution. Given differential equation. 2x square y minus 3y square into dx plus 2x cube minus 12xy plus log y into dy equals to 0. Consider the given equation as equation 1. Okay, which is in m dx plus n dy equals to 0 form. Which is in m dx plus n dy equals to 0 form. By comparing these two, we'll get m and n. Quotient of differential dx is your m and quotient of differential dy is your n. Where m equals to 2x square y minus 3y square and n equals to 2x cube minus 12xy plus log 1. If the partial derivative of m with respect to y is equals to partial derivative of n with respect to x, then we can say that the given differential equation is an exact equation. So now let's find the partial derivative of m with respect to y and partial derivative of n with respect to x. This is your m and this is your n. Partial derivative of m with respect to y equals to dou y of for m 2x square y minus 3y square. Since we are doing partial derivative with respect to y, so here x will be treated as constant. This is equals to partial derivative of first term with respect to y minus partial derivative of second term with respect to y. This is equals to constant into partial derivative of y with respect to y minus constant into partial derivative of y square with respect to y is equals to 2x square into partial derivative of y with respect to y is 1 minus 3 into partial derivative of y square with respect to y is 2y, which is equals to 2x square minus 3 2s are 6y. Therefore, partial derivative of m with respect to y is equals to 2x square minus 6y. Now let's find the partial derivative of n with respect to x. Partial derivative of n with respect to x equals to dou by dou x of for n 2x cube minus 12xy plus log y is equals to partial derivative of x. Okay, so here we are doing partial derivative with respect to x, so y will be treated as constant. This is equals to partial derivative of first term with respect to x minus partial derivative of second term with respect to x plus partial derivative of third term with respect to x. This is equals to constant into partial derivative of x cube with respect to x minus constant into partial derivative of x with respect to x plus here log y is constant. So partial derivative of a constant with respect to x is 0. Is equals to 2 into partial derivative of x cube with respect to x is 3x square minus 12y into partial derivative of x with respect to x is 1, which is equals to 2 3s are 6 x square minus 12y. Therefore, partial derivative of n with respect to x is 6x square minus 12y. So it is clear that the partial derivative of n with respect to y is not equals to partial derivative of n with respect to x. Therefore, partial derivative of n with respect to y is not equals to partial derivative of n with respect to x. From this we can say that the given equation is non-exact, right? Since the given equation is non-exact, so we need to reduce the given equation to an exact equation. Okay, the given equation is non-exact and also it is non-homogeneous. We can check the equation by reducing it to dy by dx equals to some function of x, y, a function of kx, ky equals to function of x, y. Then we can say that the given function is homogeneous and the differential equation involving homogeneous function is a homogeneous differential equation. Otherwise, it is called as non-homogeneous differential equation. Okay, if f of kx, ky is not equals to f of xy, then we call this equation as non-homogeneous differential equation. You can check it. Okay, fine. And also you can look at the equation. If we get same powers in all the terms, then we can say that the given equation is homogeneous. Okay, let's see. You're having 2 plus 1 is 3. Here you're having 2 3, 1 plus 1 2, and here you're having log y. Okay, so since you're having log y, from this we can say that the given equation is non-homogeneous. Okay, and also the powers are not same. So the given equation is non-homogeneous and also it is not in y into some function of x into y into dx plus x into some function of x y into dy equals to 0 form, right? So using m and n partial derivatives or observing m and n partial derivatives, we'll choose the suitable formula in order to find integrating factor. Okay, so coming to n, you're having log y. Okay, but in the partial derivatives you don't have any log terms, right? So we won't use n. And coming to m, you're having m equals to 2x square y minus 3y square. Okay, so now take y common from these two terms and you'll get 2x square minus 3y. So there is a possibility of finding integrating factor using m and partial derivative. 1 by m times partial derivative of n with respect to x minus partial derivative of m with respect to y is equals to 1 by, for m, y times 2x square minus 3y into partial derivative of n with respect to x is 6x square minus 12y minus of partial derivative of m with respect to y is 2x square minus 6y, which is equals to 1 by y times 2x square minus 3y into 6x square minus 12y minus 2x square minus to minus plus 6y, which is equals to 1 by y times 2x square minus 3y into 6x square minus 2x square is 4x square minus 12y plus 6y is minus 6y, right? Now take 2 common from these two terms and you'll get 2 times 2x square minus 3y by y times 2x square minus 3y, where 2x square minus 3y gets cancelled and this is equals to 2 by y. Okay. Therefore, this is equals to 2 by y. We don't have x here, right? This function does not involve any x. So we call it as function of y alone and we'll name it as g of y. Then our integrating factor will be e power integral g of y dy. What happens if we get a real number instead of function of y? Suppose k, if we get k, which is a real number, then our integrating factor will be e power integral k into dy. Okay? This is equals to e power integral for g of y 2 by y into dy is equals to e power 2 into integral 1 by y dy, which is equals to e power 2 log mod y, which is equals to e power 2 log y then integrating factor equals to e power, we know that m log n can be written as log n power m, then we'll write 2 log y as log y square, and we know that since e power log some function of y is equals to function of y, here g of y in the sense function of y, not this particular 2 by y. Okay, here y square is a function of y, right? Then we'll get e power log function of y equals to function of y. So here our integrating factor is y square. Therefore, integrating factor is y square. Now, the given equation is reduced to an exact equation by multiplying it with this integrating factor. Y square times the given equation gives exact equation. Consider as equation 2. Then y square times 2x square y minus 3y square into dx plus y square times 2x cube minus 12xy plus log y into dy equals to 0. Then multiply these two terms with y square, you'll get 2x square y into y square y cube minus 3y square into y square is 3y power 4 into dx plus multiply all these three terms with y square, then you'll get 2x cube y square minus 12x y into y square y cube plus y square log y into dy. Into dy equals to 0, which is in m1 dx plus n1 dy equals to 0 form. Where by comparing these two, we'll get m1 and n1. Coefficient of differential dx is your m1 and coefficient of differential dy is your n1. There m1 equals to 2x square y cube minus 3y power 4 and n1 equals to 2x cube y square minus 12x y cube plus y square log y. If the partial derivative of m1 with respect to y is equals to partial derivative of n1 with respect to x, then we can say that the reduced equation, that is equation obtained by multiplying integrating factor to the given equation, is exact. Okay. So now let's find the partial derivatives. Firstly, we'll find the partial derivative of m1 with respect to y is equals to dou y of for m1 2x square y cube minus 3y power 4. Here we are doing partial derivative with respect to y, so x will be treated as constant. This is equals to partial derivative of first term with respect to y minus partial derivative of second term with respect to y is equals to constant into partial derivative of y cube with respect to y minus constant into partial derivative of y power 4 with respect to y is equals to 2x square into partial derivative of y cube with respect to y is 3y square minus 3 times partial derivative of y power 4 with respect to y is 4y cube, which is equals to 2 3s are 6 x square y square minus 3 4s are 12 y cube. Therefore, partial derivative of m1 with respect to y is 6x square y square minus 12 y cube. Now let's find the partial derivative of n1 with respect to x. Partial derivative of n1 with respect to x equals to dou y dou x of for n1 2x cube y square minus 12xy cube plus y square log y is equals to, since we are doing partial derivative with respect to x, so y will be treated as constant here. Partial derivative of first term with respect to x minus partial derivative of second term with respect to x plus partial derivative of third term with respect to x is equals to constant into partial derivative of x cube with respect to x minus constant into partial derivative of x with respect to x plus partial derivative of a constant with respect to x is 0 is equals to 2y square into partial derivative of x cube with respect to x is 3x square minus 12y cube into partial derivative of x with respect to x is 1, which is equals to 2 3s are 6 x square y square minus 12y cube. Therefore, partial derivative of n1 with respect to x is 6x square y square minus 12y cube. So, it is clear that the partial derivative of m1 with respect to y is equals to partial derivative of n1 with respect to x. Therefore, partial derivative of m1 with respect to y equals to partial derivative of n1 with respect to x equals to 6x square y square minus 12y cube. From this we can say that equation 2 is exact. Now we need to find the general solution to the given equation. So the general solution of equation 2, that is an exact equation, will be the general solution to the given equation. So now we need to use the general solution of exact equation. Okay, therefore we know that the general solution of an exact equation which is in m1 dx plus n1 dy equals to 0 form is given by integral over x m1 dx plus integral of terms of n1 free from x into dy equals to c. Now consider the first integral, integral over x m1 dx. Integral over x m1 dx. Here we'll be integrating m1 with respect to x, treating y as constant. Is equals to integral of for m1 2x square y cube minus 3y power 4 into dx is equals to integral 2x square y cube dx minus integral 3y power 4 dx is equals to, let's write the constants outside the integral. Here 2y cube and 3y power 4 are constants, so we'll write the constants outside the integral. Then you'll get 2y cube into integral x square dx minus 3y power 4 into integral dx is equals to 2y cube into integral x square dx is x cube by 3 minus 3y power 4 into integral x dx is, integral dx is x. This is equals to 2x cube y cube by 3 minus 3xy power 4. Okay. Therefore, integral over x m1 dx is 2x cube y cube by 3 minus 3xy power 4. Now, consider the second integral. Integral of terms of n1 free from x into dy. So this is your n1, right? So the terms which are free from x is y square log y. So integral terms of n1 free from x is y square log y into dy. Now we'll evaluate this integral using Euler rule. You're having one algebraic term and one logarithmic, right? Since logarithmic comes first, so this will be your f of y, function of y, right? And algebraic comes next, so this will be your second function. Okay, log y is your first function, y square is your second function. Now we'll use the integral by parts formula. We know that integral f of y g of y into dy is equals to f of y into integral g of y dy minus integral of f dash of y into integral g of y into dy to dy. Right? Now we'll use this formula. Is equals to f of y log y into integral g of y, integral y square dy minus integral of f dash of y log y whole dash into integral g of y square dy into dy. This is equals to log y into integral y square dy is y cube by 3 minus integral of derivative of log y is 1 by y into integral y square dy is y cube by 3 into dy, which is equals to y cube log y by 3 minus integral of, here 1y gets cancelled and you'll get y square by 3 into dy is equals to y cube log y by 3 minus, you can write the constant outside the integral, that is 1 by 3 outside the integral, then you'll get 1 by 3 into integral y square dy, which is equals to y cube log y by 3 minus 1 by 3 into integral y square dy is y cube by 3, which is equals to y cube log y by 3 minus y cube by 3 is 9. Now, coming to the general solution of equation 1. Therefore, the general solution of one is result obtained from the first integral 2x cube y cube by 3 minus 3x y power 4 plus result obtained from the second integral is plus y cube log y by 3 minus y cube by 9 equals to c. Now take the LCM of 3, 1, 3, 9. Or LCM of 3 and 9. 3 ones are, 3 threes are. So 3 threes are 9 is your LCM. The numerator you'll get, so in the first term or in the denominator of the first term you're having 3, right? Close 3, then you'll get 3 times 2x cube y cube minus 3 nines are 27 x y power 4 plus, again here in the denominator you're having 3, so in the numerator you'll get 3 times y cube log y minus, here in the denominator you're having 9, 3 threes are 9, so you'll get y cube equals to c. Then 3 twos are 6 x cube y cube minus 27 x y power 4 plus 3 y cube log y minus y cube equals to c into 9, 9c. Since c being constant, you can write 9c as c. Then you'll get 6x cube y cube minus 27x y power 4 plus 3y cube log y minus y cube equals to c, which is the required general solution. So this completes the problem. So we have seen a problem from a non-exact equation in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.